Today we're going to look at steps for solving parts per million questions. The example we're going to use is question 5 from the spectroscopy quiz. The first step in any of these is to plot a calibration graph using our standards. The x-axis will be concentration, usually in parts per million or milligrams per litre, and the y-axis will be absorbance. In this particular question, the graph has already been given for you, so you don't need to do this. Step 2 is to use the unknown absorbance and the calibration graph to find your unknown concentration. So in question 5, if you read off this graph, you can get the answer with 0.31, and that'll read off as 5.8 parts per million, which is equivalent to 5.8 milligrams per litre. You can convert to any other equivalent unit that's useful. Step 3 is to calculate the mass of the unknown in the volume of the volumetric flask. In this case, the volume is 100 mils, so we've got 5.8 milligrams per 1,000 mils. So if we get the 100, divide that by 1,000, multiply that by 5.8, we'll end up with 5.58 milligrams. Step 4 is to use this mass to find the concentration in the original mass of sample. So in this case, we've got a 3 gram sample, so we've got 0.58 milligrams in our 3 gram sample. Then we need to, in step 5, convert this concentration to the required units. Well, actually I'm converting the mass to the required units, which will be percentage weight per weight or parts per million. So if we've got 0.58 by 10 to the minus 3 grams in 3 grams, and we want to get that into percentage weight per weight, that's grams per 100 grams. So 100 divided by 3.0 times 0.58 by 10 to the minus 3 will give us 0.019% weight per weight. You can use these steps for any of these sorts of problems, such as question 8 in the spectroscopy quiz, or questions 30 and 31 in your checkpoints. So if you need to practice doing these questions, just continue to replay this little presentation a number of times until you get the steps familiar with the steps. Okay, get to it and do some more problems.